we deal with the summation of a finite arithmetic series, you still do everything the same. It's going to still be easier because I'm going to give you a formula to help make it easier so it doesn't prolong different types of problems. So whenever we do this, if you have there we go. So whenever you have an arithmetic series, it's the same thing as having a sequence, but now we're just going to add everything up. Okay, it's the sum of the first n number of terms, however many that is, denoted by S sub n. Okay, S meaning series, or you can think about it as meaning the sum. So the first thing we want to do is we always want to find the rule, okay, for everything. So like if we find the sum, okay, first off, are they arithmetic? Okay, why are they arithmetic? What form does each problem have? Here, what do they all look like? Well, they all look like a slope of a line, or y equals mx plus b, right? So that's what's going to make it arithmetic. If it looks like y equals mx plus b, it's going to be arithmetic. So like in the first case where we're going to start with the first value and we're going to go 7 values in. It's a series, so we're going to find the sum of all of those. So what we're going to do, or what you would do, is basically plug in 1 all the way to 7 and add everything up. So I would take 2 times 1 plus 3, 2 times 2 plus 3, 2 times 3 plus 3, 2 times 4 plus 3, times 5 plus 3, 6, and then 7. So once I find what every number is in my sequence, what makes it a series is whenever I add everything up. So 5, 7, 9, 11, 13, 15, and 17. So the sum of this series, I'm just going to add everything up and get 77. Now, do you want to have to plug every single value in? No. Okay? Not even if there's 7. You probably don't even want to do it, let's be perfectly honest, if you have to go 3 times 3 minus 7 and only go to 6. Okay? This one only has 4 values that we actually have to plug in. But realistically, you're not even going to want to do that. I don't blame you. I wouldn't either. Okay, so there has to be a simpler way. Right? So instead of just having to plug in every single value and take 9 and 12 and 15 and 18 and add everything up and get a total of 26. No, not 26. Oh, that's minus, isn't it? Not a plus. My fault. Nine minus 7. So 2, 5, 8, and 11. So yes, 26. My fault. So you're not going to want to add everything up or plug everything into your formula however many times. It doesn't matter if there are 8 different things that you have to do, or 7, or even 4. So your easier way of doing this is going to be to use this formula right here. Everything still applies the same way as it did yesterday. We still have a sub 1. Now we don't have to worry about the common difference. We care about two things, or I guess three. We care about how many numbers of terms are in the sequence. We care about the first term, and we care about the last term. Okay, so you need three things to be able to solve an arithmetic series, okay, if it's finite. You need the first term, you need the last term, and you need to know how many terms we're dealing with. The good thing is the last term and however many terms we're dealing with are going to work hand in hand together. So instead of, you're not going to want to put 20 different values down, or even 15. So again, and I'll put it here, that S sub n is equal to n times a sub 1 plus a sub n all over 2. So just like we did yesterday, but yesterday we dealt with the common difference in the first term. You're still going to have to plug values in. But in some cases, it's going to be fairly simple, or what I believe to be fairly simple, as what's in. How many terms are we going to talk about? 20. I'm going to take my first term. So I still actually have to plug in 3 times 1 plus 7. So 3 times 1 plus 7 gives me 10. I still need to plug in my last term. So it's going to be a sub 20, 3 times 20 plus 7, so 67. I have n, I have my first term, I have my last term. Now I can plug everything into my formula up here. So whenever I do, S sub 20, as we're dealing with the first 20 terms, is 20 times 10 plus 67 divided by 2. It does not matter to me how you, so like if you want to do everything inside the parenthesis, that's fine, and get 77 over 2 and multiply it by 20, that's completely okay. It doesn't matter to me as far as, like, for what I would do, I would just cancel out the 10 and the 2, and I would make this, or the 20 and the 2, and I would make that a 10. Okay? It's not always going to work like that, because if this number isn't even here, it's not going to be that easy. If your number out in front, if you have an even number of terms that you're trying to find the sum of, I would basically just cancel off the 2 and then take half of whatever that value is. Now, you're not going to be able to do it over here on this problem because it's a 15. That's okay. But know that that's an easier option, because 10 times 77 is a heck of a lot easier to deal with than having to take 77 dividing by 2 and worrying about a decimal, albeit it's going to be 0.5, but then you're not going to have to worry about anything else. So if I would actually add all 20 of those terms up together, I would get 770. I'm not looking to add all 20 terms together. Work smart, not hard. So even if we have an odd number, like we do here, n is 15. Find my first term and find my 15th term. So what's my first term? Positive 2, right? Negative 2 times 1 plus 4. So positive 2. What is my last term, or my 15th term? Negative 26. So negative 2 times 15 plus 4 gave me negative 26. So now I can use everything that I have to find the sum of the 15 terms. So 15 to minus 26 over 2. Find the sum. Okay, so make sure you pay attention that it's going to be negative. You can have a negative sum. That's okay. All right, that's completely all right, because as your numbers get bigger, okay, it's going down by 2 each time. So as you get into it, once you pass that third term or get to that third term, it's going to be a negative value, right? Okay, first term is going to be a positive 2. Second term is going to be at 0. The third term is going to be at a negative 2. And everything else from then on is going to be negative. Okay, so you're going to be adding negative numbers together, and that's okay. Now, here it says find the sum of the first 40 terms of the arithmetic sequence. What are we missing here? Let's look at it this way. We need to know, if we're going to do this and we're going to find the sum, okay, remember we need to know n times a sub 1 plus a sub n all over 2. What do we know? Do we have all three parts? Or are we missing something? Do we know what n is? How much? Well, but how many terms do we want to add together? Okay. Do we know what the first term is? It's 5, right? Do we know what our 40th term is? No. So here is where the problem lies, or this is where we've got to figure out what's our 40th term. So if you're missing the 40th term or the last term, what do we need to know? Or how do we find out what a sub n is? What? We need the rule? Okay. Do we know how to write the rule for a sequence? How do we know how to do that? From what? From yesterday, right? Okay. Perfect. It's like we planned to do it in this order. It's craziness. So, to write the rule, we have to know what the common difference is. So what's the difference between 5 to 13, 13 to 21, 21 to 29, 29 to 37? 8. So what is my rule? How did we do that yesterday? To find a sub n, what did we have to do? We took the first term, so in this case is 5 plus 8 times n minus 1. So what's my rule? 8n minus 3. So with that, I need to find what the 20th term, or the 40th term is, right? Yeah. So if I'm going to find the 40th term, or a sub 40, down here, I'm going to go 8 times 40 minus 3. 317? Yeah. Now do I have everything that I need? Yes, I know what I'm trying to find. The first 40 terms, or the sum of the first 40 terms. I'm going to take 40 times 5 plus 317 and then divide by 2. Again, it's completely up to you what you do. If I have 40 over 322 divided by 2, I can divide 322 divided by 2 just as well and get 161 and take 40 times 161 and get 6,440. -4, right? So we want to figure out how many total terms there are. So what if I'm going to use my formula that I was given yesterday of a sub n equals a sub 1 plus d times n minus 1? Which term do you think I probably need to look at to plug in to this equation? I want to know how many total terms I have. Where's the last term? 30. Or -30. So if you're given all the terms, or you at least know the beginning and you know the end, and you have to find how many total terms there are, I'm just going to solve for n in this equation. So -30 equals a sub 1, which is 6, minus 4 times n minus 1. I'm solving for n here. So I want to distribute that -4. So what do I need to do to solve for n? I have -30 equals -4n plus 10. Subtract 10. So -40 equals -4n. So how many terms are there? N is equal to 10. So now that I have 10, now can I go up here and go to work? Do I have all the information that I need?
Yes.
Yes. So, to find the sum of the first 10 terms, I'm going to take 10 times 6 minus 30. I'm going to divide that by 2. I'm going to have 10 over -24 . 10 times -12, so -120. At some point, you're going to be given missing information. The good thing is, from what we talked about yesterday and what we're doing today, you can figure out what part you're missing. Most likely what you're going to have to need is going to be this formula right here. Okay, a sub n is equal to a sub 1 plus d times n minus 1. Okay, you're going to have to use that rule equation or formula to help you out.